Imagine a future so distant that it dwarfs even the vastness of the cosmos. 10 quintillion years, a number so large it eludes human comprehension. To peer that far into the future is to stand at the edge of eternity, contemplating the ultimate fate of the universe. Our journey takes us through epochs of cosmic evolution, witnessing the birth and death of stars, the dance of galaxies, and the relentless march of time. The universe we know, teeming with the energy of youth, will transform into a realm almost unrecognizable to our current understanding. This is not a journey for the faint of heart. The vastness of time and space can be daunting. But for those who dare to explore the cosmos with open minds, the rewards are immeasurable. Our exploration is based on the best scientific models available today. These models, while powerful tools for understanding the universe, are still subject to revision as our knowledge expands. The future, especially on such an immense timescale, holds mysteries that we can only begin to imagine. Our journey begins with a fundamental truth. The universe is expanding. This expansion is not just a simple movement of galaxies away from each other, but rather space itself is stretching, creating more distance between celestial objects. Imagine blowing up a balloon with dots on it. As the balloon inflates, the dots move farther apart. This is a simplified analogy of how our universe behaves. Since the Big Bang, space itself has been stretching, carrying galaxies along for the ride. The Big Bang wasn't an explosion in space, it was an expansion of space itself. This expansion set the stage for the formation of galaxies, stars and planets, and continues to shape the cosmos today. This expansion, once thought to be slowing down, is now believed to be accelerating due to a mysterious force called dark energy. Dark energy makes up about 68% of the universe, yet it remains one of the biggest enigmas in modern astrophysics. Its repulsive force counteracts gravity, pushing galaxies apart at an ever-increasing rate. As the universe continues to expand, the galaxies around us will drift farther apart. This means that over billions of years, the night sky will look very different. Galaxies that are now visible will eventually move so far away that they will disappear from our view. The Milky Way, our galactic home, will eventually merge with its neighboring galaxy, Andromeda. But this combined galaxy will become increasingly isolated in the vastness of space. This cosmic dance will take place over the next few billion years, resulting in a new galaxy, sometimes referred to as Milkomeda. The expansion of the universe has profound implications for its future. As space continues to stretch, the distances between galaxies will grow, making intergalactic travel increasingly difficult, if not impossible, for any future civilizations. As space stretches, the light from distant galaxies gets stretched as well. This stretching of light is known as redshift. The farther a galaxy is, the more its light is redshifted, shifting towards the red end of the spectrum. This phenomenon, known as redshift, causes the light to become redder and fainter. Redshift is a crucial tool for astronomers, allowing them to measure the rate of expansion and understand the universe's history and structure. Over time, the most distant galaxies will fade from view, their light too stretched to be detected. This means that the observable universe will shrink, and the cosmic horizon will become more limited. The universe, once ablaze with the light of countless stars, will gradually grow darker as the expansion continues. Stars will burn out, and new star formation will slow down, leading to a more desolate and dark cosmos. This relentless expansion is a key factor shaping the universe's destiny, driving it towards a state of increasing darkness and coldness. The cosmos, once vibrant and full of light, will eventually become a cold, dark, and lonely place. Stars, the building blocks of galaxies and the engines of cosmic evolution, will not shine forever. These celestial bodies, which have fascinated humanity for millennia, are not eternal beacons in the night sky. They have life cycles, just like living organisms, and their existence is marked by a series of transformative stages. They are born from clouds of gas and dust, ignited by the force of gravity. These stellar nurseries, known as nebulae, are the cradles of star formation, where the delicate balance of forces leads to the birth of new stars. But their fuel, primarily hydrogen, is finite. As stars consume this hydrogen through nuclear fusion, they produce the light and heat that we see. This process, however, is not endless. As stars age, they consume their hydrogen fuel, eventually exhausting it. When this happens, they undergo dramatic changes, often expanding into red giants or contracting into white dwarfs, depending on their initial mass. The exact lifespan of a star depends on its mass. Massive stars, with their immense gravitational pull, burn through their fuel much more quickly than smaller stars. Massive stars live fast and die young, exploding as supernovae. These cataclysmic events scatter elements across the cosmos, seeding future generations of stars and planets. Smaller stars, like our Sun, have much longer lifespans, eventually fading into white dwarfs. These remnants, though no longer active, continue to glow faintly for billions of years. Over vast stretches of time, the rate of star formation will slow down as the raw materials for new stars become depleted. The once bustling regions of star birth will grow quiet. The universe will enter a period of stellar twilight where the birth of new stars becomes increasingly rare. This twilight phase will be marked by the gradual dimming of the cosmos. The once vibrant tapestry of starlight will begin to fade. The night sky, once filled with countless stars, will grow darker and more desolate. The universe will grow dimmer, its darkness punctuated by the fading embers of aging stars and the occasional burst of light from a supernova. These rare explosions will be the last fireworks in an increasingly dark cosmos. This era marks a significant shift in the universe's evolution, from a period of active star formation to a time of gradual decline. The twilight of the stars is a poignant reminder of the impermanence of even the most seemingly eternal aspects of our universe. As stars die, they leave behind remnants. These remnants are the building blocks of the next phase in the cosmic life cycle, a testament to the ever-changing nature of the universe. The death of a star is not an end, but rather a transformation, a rebirth into something new and often more mysterious. Some of these remnants, known as black holes, are among the most enigmatic objects in the universe. They captivate the imagination of scientists and lay people alike, representing the ultimate unknown. Black holes challenge our understanding of physics, pushing the boundaries of what we know about the cosmos. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. This immense gravitational pull warps the very fabric of space-time, creating phenomena that are as fascinating as they are perplexing. The event horizon, the boundary beyond which nothing can return, marks the point of no escape. Black holes are formed when massive stars collapse at the end of their lives. This cataclysmic event, often marked by a supernova explosion, compresses the star's core into an incredibly dense point. The resulting black hole is a remnant of the star's former glory, a compact object with a gravitational pull that defies comprehension. They are incredibly dense, packing a tremendous amount of mass into a tiny space. Imagine a mass several times that of our Sun compressed into a region no larger than a city. This density gives black holes their extraordinary gravitational strength, making them some of the most powerful objects in the universe. Their gravitational pull is so strong that they warp the fabric of space-time around them. This warping effect can bend light, distort time, and create gravitational waves that ripple through the cosmos. The influence of a black hole extends far beyond its immediate vicinity, affecting the motion of stars and gas clouds in its neighborhood. In the distant future, as stars continue to die and leave behind black holes, these enigmatic objects will become increasingly common. The universe will be populated by these dark sentinels, each a remnant of a star that once shone brightly. They will dominate the cosmic landscape, their presence a constant reminder of the life cycles of stars. They will drift through the darkness, their presence felt only through their gravitational influence on their surroundings. Invisible to the naked eye, black holes will continue to shape the structure of the universe, pulling in matter and bending light. Their silent journey through the cosmos will be a testament to the enduring power of gravity. Black holes are not eternal. Despite their immense power, they are subject to the laws of physics and will eventually meet their end. Over incredibly long timescales, they will undergo a slow process of evaporation. They slowly evaporate over time through a process called Hawking radiation, emitting particles and losing mass. This process, predicted by physicist Stephen Hawking, reveals that black holes are not completely black, but emit tiny amounts of radiation. Over eons, this radiation will cause them to lose mass and eventually disappear. However, the time scale for black hole evaporation is incredibly long, far exceeding the age of the universe today. It will take many times the current age of the universe for a black hole to evaporate completely. This means that for all practical purposes, black holes will remain a dominant feature of the cosmos for an unimaginably long time. For all intents and purposes, on the scale of tens of quintillion years, black holes will reign supreme, shaping the destiny of the cosmos. Their influence will be felt across the universe, guiding the evolution of galaxies and the formation of new cosmic structures. The new cosmic order will be one where black holes are the ultimate architects of the universe's fate. As we venture further into the distant future, we come face to face with a sobering concept: the heat death of the universe. This is a state where the universe has reached a state of maximum entropy. All energy is evenly distributed and, well, no work can be performed. It's a scenario where stars have burnt out, black holes have evaporated, and essentially all forms of energy have dissipated. The universe in this stage is cold, dark, and lifeless. It's a stark reminder of the impermanence of everything we know. But even in this seemingly bleak future, there is a strange beauty in the inevitable calm that follows the cosmic storm. As we delve into the mysteries of the universe, we encounter the cosmic background radiation. This faint glow, a remnant from the Big Bang, whispers secrets of the universe's infancy. It's like an ancient photograph, capturing the moment when everything began. Moving forward, we ponder the fate of humanity. What lies ahead for our species? Will we venture beyond the stars, or will we find ways to thrive on our home planet? The choices we make today will shape the destiny of generations to come. Now, let's consider the limits of knowledge. There are boundaries to what we can understand, at least for now. But isn't it fascinating how each discovery pushes those boundaries a little further? It's a never-ending quest, driven by curiosity and the desire to know more. Finally, we observe a universe in perpetual transformation. Nothing remains static. Everything evolves. Stars are born and die, galaxies collide, and new worlds emerge. This constant change is the heartbeat of the cosmos, a reminder that the universe is alive, dynamic, and ever-changing.